Okay, we're going to finish the last chapter for our final study guide. So we're going to look at the definition of energy. This is energy and work, and also mechanical advantage, ideal mechanical advantage, and efficiency. So energy, first of all, is measured in joules. So let's put this little J there. And definition of energy is the ability to do work. So it's the ability to do some type of work. And we have this theory, and it's the work-energy theorem, where the work is equal to the change in energy. Kinetic energy. Kinetic energy is the energy of motion, so it's not surprising that we find velocity in kinetic energy. So kinetic energy, K, is equal to 1/2 mv squared. Okay, it's the energy of motion. If you increase the mass while maintaining the same velocity, you have more energy. And also, if you increase the velocity of an object with the same mass, you will also increase the kinetic energy. Okay, on to our last page. We have the work formula, the definition, and what it means. So work is equal to force times distance. Here's the formula. And what it means is that when you apply a force and move an object, you'll be doing work. So work is applying a force over a distance. And as we discussed in lecture, if your distance is equal to 0 and you don't move it, then you don't do any work whatsoever. Since work is equal to energy, the units of work are going to be also in joules, as kinetic energy is also in joules. And increasing the work increases the energy of the system. So if we are increasing the work, and work is equal to the change in kinetic energy, what must be happening is this. The change in kinetic energy is the final kinetic energy minus the initial kinetic energy. And if I've increased my work, I must be having a higher final kinetic energy. Okay, so for example, you're driving down the freeway and you're going at 50 miles per hour and you speed up. So if you increase your final velocity, you're going faster. If you're going faster, remember K is equal to 1/2 mv squared. That means your K2 is going to be higher. How do you go faster? You have to have more work to go faster. More work is done in the car to make it go faster. Decreasing the work decreases the energy of the system. We can also see this in the formula work is equal to force times distance. If you decrease the distance that you move an object, you're going to be doing less work. Or using the prior example, if you're going to be going slower, you're going to be decreasing your work as well. So the power formula, remember, power is a rate. It's like velocity. It's how fast that the work is being accomplished. And the formula for this is the power is equal to work over time. And remember, work is equal to force times distance over time. And if you're lifting a box, the F is the Fg, which is m times g. So this could translate into m times g times the d all over time. What's the goal of a machine? Well, we did the pulleys and we discussed that it's not to do less work. The goal of a machine is to decrease your effort force. We want to decrease my force of effort. However, in order to accomplish this, you actually have to increase the distance at which you move it. So there's this conservation of energy where the work out is going to be equal to the work in. So your work out, this is the object you're trying to move, which is the force of resistance, times the distance of resistance. The work in is what you are doing yourself to try to lift the box. It is your force of effort times the distance of your effort. So imagine that we have our weight in our pulley system, and we have the 5 Newton weight that we're trying to lift, and we are going to be moving that 0.10 meters or 10 centimeters. We're pulling the weight up to 10 centimeters. If we have the double pulley and we have 5 strings wrapping around that, we experience a 1 Newton force of tension on our tension scale. But the work out has to be equal to the work in. This will be equal to 0.5. So my 1 Newton times my 0.50 meters. So I will pull with a 1 Newton force on my tension scale, but I'm going to have to move that tension scale about half of a meter, or 50 centimeters. What high and low mechanical advantages mean? If you have a mechanical advantage that is greater than 1, that means you have a good machine. The higher that your mechanical advantage is, the better the machine is. So we have the force of resistance. Again, this is your F of R. We have the effort force. This is the F of E. We have the distance of resistance. This is the dr. And the effort distance, this is the dE. The force of the resistance, this is like the 500-gram weight in our pulley system. This is the weight of the actual object. Fe is your force of effort, or it's your input force. This was what was being pulled on the tension scale to lift the object. The dr is the distance the object moves. And the dE is the distance that the tension scale, or you, move. It's the distance of your effort or your input. We will go ahead and cross this one. We don't have to worry about this one. We didn't do the fulcrum and the lever system regarding work, so don't worry about that one there. So there's going to be a couple of mathematical problems, and one of them, again, is regarding work. So again, work related to up here, work is equal to force times distance. And again, the force is often going to be the weight of the object. So the work on the object is going to be, if we plug in the Fg into here, will be m times g times d for work. So power is equal to work over time. If you take your work and plug it into this formula over here, we will get m times g times d over t. It's the work over time is the power. And again, this is measured in watts, which is also capital W, just like work is capital W. You'll need to calculate the mechanical advantage, which is the force of resistance over the force of effort. The ideal mechanical advantage is the distance of the effort over the distance of resistance. Now, this is like, right here, the ideal, this is like your 100% theoretical mechanical advantage, sort of like your theoretical yield. What's the 100% possibility that you can get? So if we look at the mechanical advantage, our goal is to decrease my effort force to make it easier on me, and it will therefore increase the mechanical advantage. And the efficiency is going to be equal to the mechanical advantage over the ideal mechanical advantage times 100%. So if you're looking at ideal mechanical advantage, here's our ideal mechanical advantage over here. And if you remember, we did a little ramp and compared lifting a box up right here, which is the distance of resistance, compared to pushing it up the ramp, which would be the distance of the effort. So our goal is to decrease the effort force, but in so doing, it's going to increase. We have a larger distance to travel up the ramp. It's going to increase this, so the ideal mechanical advantage will increase as well. So the theoretical is based upon the distances, and the mechanical advantage is based upon the force of the object and the force that you actually put in, and the efficiency is this formula over there. That's it for our final review. Please let me know if you have any questions.